Hi, it's your favorite CTO here. Today I want to talk with you about globally distributed Kubernetes clusters and how to create them, how to create the global distributed applications that are working inside of the containers and are deployed using Kubernetes. And we will build such kind of the global distributed cluster using Google Cloud Platform and its new feature called Anthos. First of all, let's imagine that we need to create a system that will provide us access to the same services from the different area of the world. And we want extremely low latency between our end customer and our services. So for example, our end client in San Francisco, when he is working with our application, he need to be connected to our pods, our cluster, which is localized in United States. But for example, when we are connecting from Europe, in this example from Berlin, then we need to be load balanced, we need to be redirected to Europe West 1. And to do this, we need some kind of solution, some kind of mechanism that will provide us globally distributed load balancing for our clusters that are localized in the different part of the world. And here in Google Cloud Platform we can use something that's called Ingress for Anthos. Ingress for Anthos use a centralized Kubernetes API server to deploy Ingress across multiple clusters. And this, let's call it centralized cluster, is called config cluster. And this is the chosen Google Kubernetes Engine cluster where the multi-cluster ingress and multi-cluster service are deployed. All multi-cluster resources are deployed and are accessible through the single API localized on this cluster to retain consistency across all of the clusters. Another part of this architecture is Anthos Ingress Controller. And this is globally distributed control plane that's run outside of your cluster as a service. This allows the lifecycle and operation of our Anthos Ingress controller to be independent from our clusters. So if something happened to our clusters, our Anthos Ingress controllers still will be working. And there is something that is called environ, which is a domain that groups clusters and infrastructures, manage resources and keep consistency policy across all of our multi-cluster environment. Other clusters that are localized here on our schema are something that is called member cluster, and they are registered in our environment and can be used by our Anthos Ingress as a backend for our system. So for example, when our client enter our page or run some kind of request, he will be redirected by our ingress to the specific member cluster. Okay, so let's build such a distributed cluster in our Google Cloud Platform. To do this, we're gonna use our Cloud Shell. And first of all, we need to select the specific project. I created a new project called Kubernetes Global App. First of all, we need to enable our APIs in our Google project. First one will be Anthos API. We're gonna use command gcloud service enable anthos.googlesapis.com. It can take a while, so we need to be patient. Next thing, we need to enable another API, Google Kubernetes Engine Hub. So we will use another command to do this, and this is the command: gcloud services enable gkehub.googleapis.com. We hit the enter button and this should be really fast. Next one, we need to enable multi-cluster ingress API, so we will use another command, and this time it will be gcloud services enable multi-cluster ingress.googleapis.com, and also we hit enter and our API should be enabled also. When the operation is finished, then we need to create our clusters, and we will create our clusters in, let's call it, 2 different localizations. First one in USA and the second one in Europe. Okay, let's create our first cluster in the US. We will use this specific command: gcloud beta container clusters create, then we provide our cluster name, and then we are gonna use zone flag to specify in which zone we want to deploy our cluster. We're gonna choose a specific release channel which will be stable, and at the end we will enable IP alias using this flag. Then we hit enter and our cluster should be created. It will take a few moments, so we can make a coffee meanwhile. Okay, our cluster is already running, so let's create another one in the Europe. Let's use the same command, but let's change only the name of our cluster and the zone. So let's change the name for the GKEAN, and also let's change the zone to Europe West 1B. We hit enter and our second cluster should be deployed in a couple minutes. Meanwhile, we need to create some service accounts. So let's add another terminal and new tab. We're gonna use this command: gcloud IAM service accounts create, and here we need to put the name of our service account. Next we need to select project where our Kubernetes clusters are located, and we need to provide project ID for the specific project. Then we hit enter and our, let's call it, service account should be created. Okay, now let's check service accounts in our project. To do this, we're gonna use command gcloud IAM service accounts list project, and there we're gonna provide our project ID. And we should see different, let's call it, accounts, service accounts, and one of them should be the account that we have created before. Now we need to create a policy binding for this account so it can manage our, let's call it, connection and registration of our clusters. And we're gonna use command gcloud projects add EAM policy binding, and then we need to specify our project ID, member, and the member is our service account, and specific role. So let's do it. Okay, next thing, we need to download and create and download keys that will be used by our service. So let's use another command that will create and put a key into the JSON file. So let's use gcloud EAM service account keys create. Then we need to specify path, local path where the file with our key will be created, and then we need to specify our service account and our project using project ID. Then we hit enter and our key should be created. Let's register our cluster. We will use a command gcloud container hub memberships register, then we put the name of our cluster, then we select our project, and then we provide URI of our cluster. At the end we also provide service account key file, which is in my case key.json. Here is the typo. And now when I run this command, I should register first of my clusters, which is localized in Europe. Okay, next we're gonna register the second hub in the same way. So let's see the URI of our second cluster, and then let's just run the same command, but let's change the URI and the cluster name. All operation has completed, so now one of them should be our config cluster, and we need to set a specific cluster to be this one management cluster, one special config cluster. And we also gonna use our gcloud CLI to do this. So we're gonna use command gcloud alpha container hub ingress enable, and then we need to select our, let's call it cluster, using this specified URL. So we provide project / name of ID of our project / location / global, because we want to create the global ingress / memberships / and here we provide the name of our cluster that will be our config cluster. I choose the cluster in the Europe. You can choose whatever you want here. You can choose the cluster in the US also. And now I will just launch this command and my cluster should be set as our config cluster. There could be an error because if controller will not start in 2 minutes, we will see this error message. But don't worry about it, we can always check using command gcloud alpha container hub ingress describe and check if our ingress is enabled. And as you can see, my ingress is enabled and is working. Okay, now let's deploy our application. And very important thing to know is that in this specific scenario we have two types of Kubernetes objects, let's call it like this. First one are standard deployments, which namespaces, etc., which will be deployed to the specific cluster. So for example, our deployments, our namespaces, we need to create on both of the clusters. Only the multi-cluster ingress object and multi-cluster service object can be deployed using our configuration cluster and only there. Everything else we need to manually deploy on every cluster. And at the moment, because this is the new functionality, this is how it works. Okay, so let's create our namespace. We will use the simple YAML file, so nano namespace dot YAML, and then we will create a simple namespace called zone printer. Okay, let's save this file, and now we need manually deploy and create this namespace to both of our clusters. Let's check which context, which cluster is set as our default context in our Kubernetes CLI. We will use command kubectl config current context, and current context, when we launch this command, should be displayed. As we can see, we are now using our European cluster, so let's create a namespace kubectl apply f, and then we should provide the path to our file. It will be namespace YAML, and our namespace should be created in this specific cluster. Okay, now we need to change our context to US cluster. To do this, we need first display the list of all our contexts, so we're gonna use command kubectl config get context, and then we can see the names of our contexts. So now we can kubectl config use context, and then provide or copy the name of US cluster. Okay, then let's paste it, and now all operation that we're gonna execute by CLI will apply to our cluster in the US. Okay, so now let's apply our namespace in this different cluster. Okay, our namespace is created, so now let's create a deployment, and let's apply it, create it in both of these clusters. Let's create our deployment file, deployment YAML, and also let's paste the standard deployment configuration here. As you can see, we're gonna deploy our pods into the zone printer namespace, and we're gonna use container called Google Sample Zone Printer 0.2. Okay, now let's exit this file and let's save it, and let's apply our deployment. Let's create our deployment on our cluster in the US. So let's call kubectl apply, and now let's choose our file. Our deployment is created. Now we need to change our context again to our European context, so we gonna use this one again, and let's change current context to this context, and let's also apply our deployment here. Okay, so first let's create our multi-cluster service. To do this, we will also create a file, nano multi-cluster service.yaml, and here we're gonna paste our code. As you can see, we're gonna create Kubernetes object. Kind of this object will be multi-cluster service. We will call it zone MCS. We will put it in the zone printer namespace, and we will select the app called zone printer, which will be targeted on the port 8080. Okay, let's close it and save it. Now we can apply this service state to our config cluster, because now we can only apply it to the one cluster, this one specific cluster, which is our config cluster, and he will propagate the changes. So now let's create kubectl apply f, and now let's create a service. Okay, and now let's create our multi-cluster ingress. Let's create a new file called mci.yaml, and let's paste here our configuration for our multi-cluster ingress. Here, as we can see, we will create the Kubernetes object kind multi-cluster ingress. In the namespace zone printer, we'll call it zone ingress, and as we can see in the template, we will specify that ingress will have zone MCS service as its backend. Okay, let's exit it and let's save it, and now let's apply the changes to our configuration cluster, kubectl apply f, and here we're gonna use mci YAML. And now our ingress and our service should be created. Let's test our globally distributed application. kubectl describe mci zone ingress, and the namespace, of course, because by default we are working in the default namespace, so we won't be able to see all of the resources that are created in the different namespace, so we always need to specify the namespace or set our new namespace zone printer as a default namespace. Okay, and now as you can see, we have all information about our ingress, multi-cluster ingress. We can see link to it, we can see parts and the backend services. Here is the zone MCS. We can see our backend services, forwarding rules, health checks, network endpoints, and as you can see, there are two different endpoints for the US and the Europe. We can see the proxy, IP, so there's everything here, every information that we need about our multi-cluster ingress. Okay, so now let's use our IP, let's call it here our VIP, and let's paste it /ping, and now we should have the answer from our Europe cluster, because now I'm connected to the internet in Europe, and when I will use the VPN to connect to the USA, then you will see that the same address, the same URL will be directed to US cluster. So now I'm using my NordVPN to connect to the United States, and yes, now I'm connected. So at the moment this page should redirect me to my USA cluster, and as you can see, I was redirected to the US Central 1 AA cluster. So it seems that everything worked as we planned. Our application is now globally distributed, and our load balancing is based on our location. That's all for today. Thank you for watching my video. As you can see, this technology is very powerful. We can easily build globally distributed solutions, globally distributed applications. This is very useful in, for example, IoT scenarios, for gaming platforms, or for any other globally distributed system. So thank you for watching this and see you in the next episode.